The new American nuclear renaissance was supposed to begin in 2009. That was the year construction started on 2 reactors at Plant Vogtle in Georgia. They were expected to cost around $14 billion and enter service in 2016 and 2017. Instead, 1 reactor came online in 2023. The second followed in 2024. The final bill exceeded $35 billion. During roughly the same period, China connected more than 30 new reactors to its grid. Same technology, same physics, same uranium. Completely different outcomes. And this isn't just a story about electricity, because when a country loses the ability to build a nuclear plant efficiently, it may be losing something much larger. The ability to coordinate capital, train skilled workers, manufacture complex components, and execute projects that take a decade to finish. A nuclear reactor is, in some ways, an industrial civilization taking an exam. China keeps passing. The United States keeps asking for an extension. Here's a number that doesn't get enough attention. According to the International Atomic Energy Agency, China currently has the world's fastest-growing nuclear fleet and has approved dozens more reactors for construction. At the pace of recent approvals and completions, Beijing is effectively adding a major reactor roughly every 8 months. The United States has finished exactly 2 new large reactors in the last quarter century. That difference matters because electricity demand is changing again. Artificial intelligence data centers are becoming enormous consumers of power. Manufacturing is returning home in strategic sectors. Electric vehicles, battery factories, semiconductor fabs, all of them need reliable electricity. And the uncomfortable arithmetic is simple. A modern economy can survive expensive power. It struggles with unreliable power. It eventually declines with insufficient power. This is why governments from France to South Korea are returning to nuclear energy after years of hesitation. They aren't doing it because nuclear is fashionable. They are doing it because the alternatives are running into limits, whether that's land use, intermittency, fuel imports, or politics. The irony is almost dry enough to be funny. For decades, America taught the world how to build nuclear reactors. The first commercial reactor opened in Pennsylvania in 1958. American firms exported technology globally. South Korea's reactor industry traces part of its lineage back to American designs. China's latest CAP-1000 reactors are descendants of Westinghouse technology. The teacher is now importing lessons from its students. And before this turns into another simplistic China good, America bad argument, let's slow down. China has advantages that Washington doesn't. Beijing can direct state-owned banks, accelerate permits, and align provincial governments with national goals in ways democracies often cannot. Labor costs were lower for years. Land acquisition is easier. Political resistance is weaker. Those are real advantages, but they don't explain everything. France is a democracy and built one of the world's most successful nuclear fleets. South Korea is a democracy and became one of the most efficient reactor builders on Earth. The United States itself built more than 100 reactors during the 20th century. So the question isn't whether democracies can build nuclear plants. The question is why one of history's greatest industrial powers suddenly forgot how. That answer takes us somewhere unexpected. Because nuclear reactors are not really about concrete and steel. They're about memory, industrial memory, the kind that exists in welders who know how to work on reactor vessels, engineers who have overseen 5 projects before, suppliers that manufacture components every year instead of every decade, regulators that review applications continuously rather than rediscovering procedures from scratch. Lose that memory and every project starts from zero. And starting from zero is incredibly expensive. One former nuclear executive described the problem in blunt terms. America didn't merely stop building reactors, it stopped being a country that routinely builds reactors. There is a difference. Remember that distinction because it becomes important later. If this were only an energy story, it would already matter. But nuclear power is also a proxy for shipbuilding, for semiconductor fabs, for transmission lines, for advanced manufacturing, for whether a nation can still translate ambition into physical reality. Because the same country that struggles to finish reactors also struggles to build high-speed rail, transmission infrastructure, and sometimes even ordinary housing fast enough. Different sectors, similar symptoms. China's reactor program isn't proving that one political system is superior to another. It's exposing something narrower and perhaps more troubling. Some countries have retained the muscle memory of building. Others have spent decades assuming they would never need it again. and history has a habit of charging interest on assumptions. The easiest explanation is that America chose not to build nuclear reactors for a while and then found it difficult to restart. That's true. It's also incomplete. Imagine you shut down an aircraft factory for 20 years. The building still exists, the blueprints still exist, some of the machines are still there, but the people are gone. The foreman retired, the welders changed industries, suppliers closed, apprentices never arrived because there were no projects to train on. The institutions remain on paper, but the living knowledge has evaporated. Nuclear power works the same way. Between the late 1970s and the early 2000s, the United States essentially stopped ordering new reactors. The accidents at 3 Mile Island accident and later Chernobyl disaster changed public opinion and financial markets. Utilities became cautious. Regulators became more demanding. Cheap natural gas eventually made new reactors look uneconomic. The industry entered a long hibernation, and hibernation has consequences. By the time Plant Vogtle finally began construction in 2009, the United States had not completed a new large reactor in decades. There were engineers working on the project who had never seen a reactor built from the ground up. That is an extraordinary sentence. The world's largest economy was trying to restart one of its most complicated industries, with an entire generation missing. Then things started going wrong. Modules arrived late. Designs changed during construction. Contractors made errors that had to be corrected. Documentation requirements multiplied. Costs climbed. Then one of the project's key contractors, Westinghouse Electric Company, filed for bankruptcy protection in 2017. A nuclear reactor had become so expensive and complicated that it nearly destroyed one of the most famous names in the industry it helped create. Meanwhile, China was doing almost the exact opposite. It kept building. That sounds too simple, but repetition matters. China's first major push into nuclear energy accelerated in the early 2000s. Beijing didn't build one reactor and then pause for 15 years. It built fleets of reactors. Construction teams moved from one project to the next. Supply chains had continuous demand. Manufacturers could justify investments because they knew another order was coming. There is an old saying in manufacturing, you don't rise to the level of your ambitions, you fall to the level of your systems. China built systems. The United States built projects. Those are different things. Consider reactor pressure vessels, among the most difficult components in a nuclear plant. Only a small number of companies on Earth can manufacture them to the required standards. If domestic demand disappears for years, suppliers leave the business. Then, when you decide to build again, you discover that the industrial ecosystem you assumed was waiting patiently for your return has moved on. This isn't unique to nuclear power. American shipbuilding tells a similar story. Commercial shipyards declined. Supplier networks shrank. Skilled labor became scarce. Rebuilding capacity turned out to be much harder than preserving it would have been. Industrial capability isn't a switch. It's a garden. Ignore it long enough and something else grows there. And here's where the story gets uncomfortable, because some people argue that this doesn't matter anymore. Their case goes like this. America is a service economy. It designs software, develops advanced technologies, and finances innovation. Manufacturing can happen elsewhere. Building reactors slowly is unfortunate, but not existential. It's a respectable argument. I don't buy it. Because the 21st century keeps producing crises that reward physical capacity. The pandemic rewarded countries that could manufacture medical supplies. The semiconductor shortage rewarded countries that could produce chips. The war in Ukraine rewarded countries that could manufacture artillery shells faster than they could be fired. Artificial intelligence is rewarding countries that can build power generation and data centers at enormous scale. Again and again, the world keeps asking the same question. Can you still make things? And if you can, how quickly? This brings us back to that number from the opening. One major reactor roughly every 8 months. A nuclear reactor isn't just another power plant. It is millions of components, thousands of workers, years of planning, specialized steel, precision manufacturing, regulatory coordination, and financing structures that survive election cycles. If you can repeatedly build those, you're demonstrating something larger than engineering competence. You're demonstrating state capacity, and state capacity may become one of the defining competitive advantages of this century. Because there is a reversal hiding inside this story. For years, people assumed the digital economy would make heavy industry less important. The opposite may be happening. The more digital the world becomes, the more it depends on physical infrastructure, power stations, transmission lines, semiconductor fabs, ports, and data centers consuming electricity on a scale that would have sounded absurd 20 years ago. The cloud, it turns out, is made of concrete, copper, and steel, and countries that forgot that lesson are being forced to relearn it. Let's make the argument against all of this. China builds reactors quickly because it accepts risks that Western countries don't. Permitting is faster, land acquisition is easier, public opposition carries less weight, state-owned banks can absorb losses that private investors would never tolerate. There is truth in that. And if the story ended there, it would simply be another comparison between different political systems. But then you run into a problem: France. In the 1970s and 1980s, France built one of the most successful nuclear programs in modern history while remaining a democracy. At one point, it was connecting multiple reactors to the grid every year. Today, around 70% of French electricity still comes from nuclear power. Then there's South Korea. Its reactors are among the most cost-effective in the world. Korean firms didn't achieve that by cutting corners or ignoring safety. They achieved it by standardizing designs, maintaining supply chains, and building continuously. Different political systems, similar outcomes. The common denominator isn't authoritarianism, it's repetition. Industrial learning curves are real. The first reactor of a new design is expensive, the fifth is cheaper, the 10th is faster. Workers learn, suppliers improve. Mistakes aren't repeated because the people who made them are still around to avoid making them again. The aerospace industry understands this instinctively. You don't build one passenger jet every decade and expect efficiency. You build hundreds. Nuclear power forgot this lesson in many Western countries. China didn't. And this is where the numbers become difficult to ignore. According to the World Nuclear Association, China has more than 50 operating reactors and dozens more under construction or approved. The country expects nuclear capacity to continue expanding well into the 2030s. The United States still has the world's largest operating fleet by total generation, and that's an important caveat. America's existing reactors perform remarkably well. Capacity factors regularly exceed 90%, among the highest in the energy sector. In other words, the United States is very good at running reactors. Building new ones is the problem. That distinction matters, because you can coast on past investments for a surprisingly long time. Then one day you can't. This is the reversal I kept coming back to while researching this. The issue isn't that America has already lost its industrial capabilities. The issue is that many of its strengths are inherited. The existing nuclear fleet was largely built between the 1960s and 1990s. Much of the electric grid dates back decades. Critical infrastructure often reflects decisions made by previous generations. A country can look powerful for a very long time while quietly consuming industrial capital accumulated in another era. Eventually, the bill arrives. Consider transmission lines. The United States needs thousands of miles of new high-voltage lines to support AI, electrification, and manufacturing growth. Yet major projects often take a decade or more because of permitting disputes and fragmented authorities. Semiconductor fabs face similar challenges. Housing does too. Different sectors, the same recurring friction. A system that has become extraordinarily good at planning and extraordinarily bad at execution. That may sound harsh. I don't mean it as an insult. I mean it as an observation. The United States remains one of the world's most innovative economies. It dominates software, advanced research, venture capital, and frontier technologies. But innovation and implementation are not the same thing. The person who designs a bridge and the person who builds it are both necessary. Sometimes we talk as if only the first job matters. There is also a geopolitical dimension here that often gets missed. China's reactor program isn't merely about reducing coal consumption or meeting climate targets. Nuclear exports create influence. Chinese companies are already pursuing reactor projects abroad. Every plant built overseas creates decades-long relationships involving fuel supply, maintenance contracts, engineering services, and financing. Infrastructure has a long memory. A port can shape trade routes for generations. A reactor can shape energy dependencies for half a century. The United States understood this once. That's partly why American reactor designs spread around the world during the Cold War. China understands it today. I have one lingering doubt, though. Can China maintain this pace indefinitely? Building reactors quickly is one thing. Managing costs, integrating power markets, handling aging plants decades from now, and balancing nuclear with renewables is another. Every energy system eventually encounters trade-offs. No country escapes engineering realities. But even if China's pace slows, something important has already happened. It is demonstrated that large-scale industrial execution is still possible in the 21st century. That shouldn't be a controversial statement. Yet in some Western debates, it almost feels like one. And perhaps that's the most revealing fact of all. Let's go back to the beginning. Plant Vogtle started construction in 2009 and entered service years late and tens of billions of dollars over budget. During that same period, China kept pouring concrete, training workers, ordering components, and connecting reactor after reactor to the grid. The reactors matter. The pattern matters more. Because when you step back, this isn't really a video about nuclear energy. It's about whether advanced societies can still undertake difficult projects that require patience, coordination, and competence across multiple administrations and business cycles. Nuclear reactors are simply a very expensive way of asking that question. And unlike political speeches, reactors produce measurable answers. You either finished the plant or you didn't. You either built the transmission line or you didn't. You either manufactured the ships, the semiconductors, the power stations, or someone else did. There's no press release that changes those outcomes. I think this is one of the defining competitions of the next 20 years. Not capitalism versus socialism, not democracy versus authoritarianism, capability versus drift. Countries that can translate plans into physical infrastructure will have advantages that compound over decades. They'll attract energy-intensive industries. They'll support artificial intelligence at scale. They'll manufacture more of the technologies they depend on. Their supply chains will be harder to disrupt. Countries that struggle to build will increasingly find themselves buying capacity from others. That has consequences for wages, for energy prices, for national security, and for something less tangible, confidence. People trust institutions that can still do difficult things. They lose faith in institutions that keep announcing projects and then explaining why they became impossible. There is, however, a reason for cautious optimism. Industrial memory can be rebuilt. South Korea did it. France did it. The United States itself has reinvented entire industries before. During World War II, American shipyards went from launching a vessel every few months to producing Liberty ships in a matter of weeks. The Apollo program compressed technological timelines that looked impossible. Capability isn't genetic, it's a habit. Habits can return, but only if you admit they've been lost. My opinion is straightforward. America's nuclear problem is not fundamentally an energy problem. It is an execution problem. The reactor delays are symptoms of a broader difficulty in organizing capital, regulation, labor, and political will toward a shared physical objective. That diagnosis may sound severe. I think it's actually encouraging. Execution problems can be fixed. Physics problems are much harder. The question I keep coming back to is this: what happens when artificial intelligence, electrification, and reindustrialization all begin demanding enormous amounts of power at the same time? Because that demand is coming, whether governments are prepared or not. And the countries that can build generation capacity quickly will enter the 2030s with a very different set of options than those that cannot. So here's my prediction. Within 10 years, nuclear power will no longer be discussed primarily as a climate technology. It will be discussed as an industrial technology, a national competitiveness technology, a strategic asset in the same category as semiconductor manufacturing and advanced computing. And if that prediction is right, historians may look back at China's reactor construction program not as an energy story, but as an early indicator of a much larger shift, the return of infrastructure as a measure of national power. One final thought. Remember that line from the opening? A nuclear reactor is an industrial civilization taking an exam. The exam isn't over, but the grading has already begun. If you made it this far, I'd be curious where you land on this. Has America merely paused its ability to build, or has something deeper changed? Let me know below. And somewhere in China, while this conversation is happening, another reactor is probably already under construction. That by itself is a data point worth sitting with.